Hey there, Mr. Hayes. It's me. You are here to see Mr. Hayes' World of Math, and I'm guessing to get some help prepping for your AP Stats exam. We are going through CED 6. That is all of the testing and competence intervals on proportions, which is categorical data. So we're going to talk through this. This problem right here that we're talking about is the FRQ from the 2021 test, number 4. And it's going to ask you to run a significance test. So let's get to it. Manager of a large company sells pet supplies online. Manager believes that if they send past customers a $10 coupon off, more than 40% will place an offer. So this already, you can tell, this is the part, as I've circled, is going to be the part that we're testing. So that's your p-value. To investigate, they sent 90 customers who placed an order in the past were selected at random, so that's good. We'll need that later. Each of the selected customers were sent an email, and 38 placed an order. So 38 out of 90 placed the order. So then this, oh no, pardon me 1 second. Come on. There we go. So my p hat is right here. So it's 42.2. Not a huge difference. So we'll see where this goes. So they ask us to do this provides convincing statistical evidence at the 5% level of the manager's belief is correct. So let's talk through that. So your choose here needs a little bit more than what you'd have for a confidence interval, but since they're saying alpha is equal to 5%, kind of going there. Say one sample t-test for p, because we have one sample, and we're using the z-test, z-test for p. Alpha obviously is here, as already mentioned. P, this part's very important. You always have to talk about what we're actually testing. So we're trying to find the true proportion of customers who will place an order. Probably should say returning customers. And then again, since we're running a test, we need null hypothesis and an alternative hypothesis. The null hypothesis is what they think is happening up here, which is going to be the p is 40%. And he wants it, he believes it's going to be higher, and they tell you that. Oh, and they tell you that right here. This, as I said, is your alternative hypothesis. Okay, so he's assuming that the regular is about 40%. He thinks it's going to be higher than that. I would recommend that he goes back in line and actually see if he has a better number than that, but whatever. This is not, we're not getting paid for this, so we're just going to kind of do the basics. Check. Is it random? 90 customers were selected at random. That's good. Oops. Independent, change the color, apologies. 90 is definitely less. We're going to assume that's the case. And then 90, is it normal? So we're doing the n times p has to be less than 10, or he has to be greater than 10. He needs at least 10 successes and 10 failures. On this assumption here, we end up with, if he had 40, he'd get 36 successes and 54 failures. So we're good on that too. So for the actual calculations, first things first, test statistic equals stat minus parameter over standard deviation. This is on your formula sheet, bottom of the first page. Good to know. And then from there, you can fill in the parts that you know. So for example, here, our test statistic is going to be z. Statistic is going to be p hat. Parameter is p over standard deviation. So we get all of this. And then we're going to plug in the parts that we know and calculate that out. Now, as a little bit of a reminder, we want to go bigger than this. So we are assuming that that's going to be 40%. Get that back. I misspoke. That is going to be 0. So here on a unit, or here on our standard curve, normal curve, we've got 0 is our mean, and then this number down here is the 4.26. That's this. So there, the z-score is 0.426, and we want to know bigger than that. So that's why we're going to have to do z-score. If you use table A, you're going to have to go 1 minus table A. Otherwise, you can use normal CDF. So 1 minus table A is going to equal our p-value. So our p-value is 0.3372, which obviously is not terribly close to 5%. So in this case here, assuming that the null hypothesis is true, because again, remember, you need to interpret what this number up over here means. there is a 0.3372 probability of getting a p hat value of or greater, that p hat is going to be greater than or equal to 0.422 purely by chance. Okay? So that's not super unlikely. So because p is bigger, p hat of the p of 0.3372, p-value of that is bigger than our alpha value of 5%, we fail to reject the null hypothesis. Remember, you can never, since we are assuming the null hypothesis is true, you can't prove that is true. That's how logic works. So we do not have convincing evidence that our proportion of returning customers would be greater than 40%. Okay? And that is all they asked you to do for that back in 2021. So obviously pause, rewind as you need to. Over here, I'm going to put on the bottom, I'm going to put the rest of the ones from CED 6. The one above it's going to be for all the ones from CED 5. If you go back to the homepage, I have a whole list of playlists for all of this other stuff. So come on back and we'll talk about whatever you need to see next time. Talk to you later.